Hi friends, good morning. I am Swati. I am here to discuss with you a few concepts regarding periodic properties. It's a most important topic with respect to your state board exams, as well as it is very important in towards your competitive exams. So which will be covered in state, CBSE, even in the first year. So now we are going to discuss about periodic properties. First of all, what is meant by periodic properties? So the behavior of the elements that how they are showing, those we call it as the properties. Then which is meant by periodic? Already you know that what is the meaning of periodic. So in our school, so from morning to evening we are used to have the 7 periods or 8 periods. Then why we call it as a periods? A change takes place with regular intervals of time. So any change takes place at regular intervals, that changes we call as a periodic changes, like day and night, seasons. Those all comes under the periodic changes. So when we come to the elements, so there are some properties repeats at the regular intervals. For the elements what we discuss, so in case of elements at present, according to the Moseley's, the measurable property is the atomic number. So when elements are arranged in the increasing order of their atomic number, so some properties are repeated. Such properties which repeated at the regular intervals of their atomic number, such properties are we called as periodic properties. Under these periodic properties we have the concepts valency, atomic size, is also called as radius, atomic radius. Next one we have the ionization energy. Ionization energy, this is also called as ionization enthalpy. Next one we have electron affinity. Next one we have electronegativity. Last we have the metallic and non-metallic properties. Metallic and non-metallic properties. Valency, atomic size, ionization energy, electron affinity, electronegativity, metallic and non-metallic properties. So already we know that the structure of periodic table. So a periodic table, any table consisting of horizontal rows and vertical columns. That horizontal rows we call as the periods, vertical columns we call it as the groups. So how these properties, periodic properties, how those are changes in group and period, that we are going to discuss. The first concept is valency. So when we come to the concept of valency, how it changes in groups and periods. So first when we come to the groups, so we know that according to the modern periodic table, totally we are having the 18 groups and 7 periods. So among those all 18 groups, so what is common among all the 18 groups? So when we come to the groups, so if you come to the, like if you take the first A group or first group or second A, then here 3rd A to 7th A, and here 8th A or 18th group. 1 to then 13 to 17 and 18 groups. So among these all groups, if you see the first A group elements, they are having the common general electronic configuration NS1, and these are having the common general electronic configuration NS2. So when we are come to the groups, all the elements which are present in a group, they are having the common valency, that is its belongings to its valency number of electrons, that is 1. So here we can find it out valency in two different ways. So valence is nothing but combining capacity according to the olden concepts. So that was informed as whether those are elements combining with their atoms of hydrogen or atoms to the chlorine or double to the number of oxygens. So according to the modern concept of valency, we can say the valency from its outer electrons. If the number of valency electrons, then valency we can say as valency is equal valence electrons. If the valence electrons are less than or equal to 4, then if the valency electrons are greater than 4, then 8 minus valence electrons, it gives us the valency. 8 valence electrons are greater than or equal to 4, it gives us the 8 minus valence electrons. And some books is given as valency is equal to group number. Valence is equal to group number, or 8 minus group number is gives us the valency. Like just now if you come to the the element sodium. So if you come to the sodium, it belongs to which group? It having the atomic number 11, it belonging to the first A group, it has the having atomic number 11 and general electronic configuration 1s2, 2s2, 2p6, 3s1. So here this is the outer electronic configuration. It has only one electron in the third orbit. Then its valency is considered as 1 as it has the valence electron 1. Like in the same manner if you come to the oxygen. So it is the having the atomic number 8. Then having the configuration ns2, 2s2, 2p4. Then totally it has the 2 plus 4, 6 electrons in its outermost shell. Then its valency is taken as 8 minus valence electron, that is 8 minus 6, that is the 2. 2 is the valency for oxygen. Like if you come for the next element, if you consider the phosphorus, it is having the atomic number 15. If you come to the electronic configuration, it has the 3s2, 3p5. So total it has the 3s2, 3p3. It has the totally 5 electron in outermost shell. Then its valency is equal 8 minus 3 plus 2, 5. 8 minus 5, that is the 3. 3 is the valency for phosphorus. Like if you come for the aluminium, it is having the configuration atomic number 13, configuration 3s2, 3p1, 3s2, 3p1, totally 2 plus 1, 3 electrons, valence electrons are 3, then valency is equal to valence electron, that is equal to 3 is the valency for aluminium. Like now this is the way of identification of valency for a particular element. Then how this trends changes. So when we come to a group, the elements which are belong to a group are having the same number of valence electrons. So due to that they are having the same common valency. So if you take the first A group elements, they are having the valency 1, second A group elements are having the valency 2, and when we come to the third A group elements are having 3, fourth A group elements are having 4, fifth A group elements are having the either 5 or 5, 8 minus 5, 3. And 6th A group elements are having the valency 6 or 8 minus 6, 2. And 7th A group elements are having the valency 7 or 8 minus 7, 1. And 8th A group elements are inert gases or noble gases. Due to its stable inert gas configuration, they are not having the valency. That's valency is considered as 0 for inert gas elements, because valency is nothing but combining capacity. Its combining capacity, these are the elements not combining with atoms of any other elements. Due to that, its valency is taken as the 0. Its valency is taken as the 0. Then when we come to the, this is regarding in groups. So all the elements which are belonging to a group, they are having the same valency. Then when we come to the periods, so when we come to the periods, it gradually increases from 1 to 4. Then after it decreases to the 0. It decreases to the 0. I hope friends this you understand good. Then we will meet again in the next video. Now we are going to discuss about the next property, that is atomic radius. Atomic radius. This is also called as atomic size, atomic radius or atomic size. So, how to define? First, what is the definition of atomic radius or size? So, as we know that total, according to the Bose atomic model, we know that the total positive charge is present at the center of the atom is called nucleus, and the electrons revolve around the nucleus in the well-defined path. That well-defined path we call as the orbital shell. Now, the distance from the atomic radius means the distance from the center of the atom, that is nucleus, to the outermost shell where the electron present. The distance we call as the atomic radius. I am repeating, atomic radius is defined as the distance from the center of the nucleus to outermost shell where the electrons are present. That distance we call as the atomic radius or size. So then what are the units? What are the units? Generally units, it is a distance. Distance units are, generally we use the meters and centimeters, and bigger unit is kilometers. But here we know that atom only invisible to us. Then the distance between the nucleus to outermost shell is very less. To measure such a smaller lengths, we are used picometers, nanometers, and the angstrom. Then 1 angstrom equal to 10 power minus 8 centimeters or 10 power minus 10 meters. 10 power minus 8 centimeters or 10 power minus 10 meters. Then next, how it changes in periods and groups. First we will discuss in case of groups. So in case of groups, like if you consider the first A group elements, what are the first A group elements? Those are the hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Then its general electronic configuration, I am writing only outer shell configuration. It is 1s1, here 2s1, here this is 3s1, here potassium is 4s1, rubidium 5s1, cesium 6s1, and francium 7s1. Now if you take the hydrogen, so the nucleus, the distance from the nucleus to first shell we called as the atomic radius. Then when we come to the lithium, the electron is present in second shell. Then from the nucleus to second shell we call as the radius. Then we know from when we come to the sodium, from the nucleus to third orbit we call as the radius. Then when we come to the potassium, then nucleus to the fourth orbit we call as the atomic radius. Now we can say that, so when we are going top to the bottom in a group, when we are going top to the bottom, the number of electrons increases. Then we come to that hydrogen, atomic number 1, lithium 3, 11, 19, 37, 55, 87. Then when we come to the, in a group top to bottom atomic number increases. So as we know that atomic number increases, the number of electrons increases. So to accommodate this number of electrons, atom requires the more number of shells. So here when we are going from top to bottom, so the number of electrons increases. To accommodate that, the number of shells or orbits increases. That's why we can say simply atomic radius increases. Atomic radius increases in case of the group from top to bottom. So what is the conclusion? In case of groups, top to bottom atomic radius increases. Then why it is increases? So when we are coming from top to bottom, atomic number increases. As a result, the number of electrons increases. To accommodate that number of electrons, number of shells increases. So atomic radius increases. Then when we come to the group, when we come to the periods, so if you consider the first, we never consider the first period. Then when we are going the second periods, then second period elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. When we come to the electronic configuration, 2s1, 2s2, 2s2, 2p1, 2s2, 2p2, 2s2, 2p3, 2s2, 2p4, 2s2, 2p5, 2s2, 2p6, 2s2, 2p6. This is the atomic radius. That means you see that all the elements which are belonging to the period, the electrons are entering into the same shell. Electrons are entering into the same shell. Then we can suspect that is the atomic radius same? Yes. Yes, according to this concept what we learned, all the electrons are filling into the same orbit. We can guess it. The atomic radius is same. But there is elements when we discuss about in the periods left to right, that is lithium to neon, in general atomic radius decreases. In general atomic radius decreases. Why the atomic radius decreases? Why the atomic radius decreases? Here, if you consider lithium, 3 atomic number 4, 5, 6, 7, 8, 9, 10. So when we are coming to the left to right, the atomic number increases. The atomic number increases means we know that atomic number is defined as the number of protons present in the atom or the number of electrons present in the neutral atom. So here at left to right, atomic number increases means the number of protons in the nucleus increases. That is, we can say as nuclear charge increases. Nuclear charge increases. So as nuclear charge increases and these all the electrons enter into the same shell, nuclear charge increases and all the electrons enter into the same shell. So the attractive power of the nucleus on outer electrons increases. The attractive power of the nucleus on outer electrons decreases. So because of that increase in nuclear charge, this nucleus, here electrons are negative charge, nucleus is positive charge. This positive charge strongly attracts the negative charge. Due to that, this nucleus slightly pulling these negatively charged electrons towards itself. Because of that, its size slightly decreases, its size gradually decreases. So I am concluding that how atomic radius changes. Atomic radius is defined as the distance between the nucleus to outermost shell where electrons are present. Its units are meter, centimeter, picometer, nanometers and angstroms. Then in a group, top to bottom atomic size increases due to increase in atomic number. Then when we come to the periods, left to right, atomic radius, left to right, atomic radius decreases. Atomic radius decreases. Why it decreases? So here all the electrons enter into the same shell, but here the nuclear charge increases. So due to that, atomic radius decreases. Atomic radius decreases. So now in case of metals, we will speak about or we will discuss about metallic radius. In case of metals, there will be the metallic radius. What is meant by metallic radius? So in case of metals, each atom not bonded to other atom, but without a bonding, those metal atoms are very close to each other. So this is the nucleus of this atom and this is the nucleus of this atom. This distance we call as the internuclear distance. Half of the internuclear distance between the two adjacent atoms of a metal crystal is called as metallic radius. Half of the internuclear distance, this is the nucleus and this is the distance between the nucleus, this we call as the internuclear distance. Half of the internuclear distance between the atoms which are bonded through a metallic bond. Such internuclear distance we call as the metallic radius. This metallic radius only measured for the metals. Metallic radius is only applicable for the metals. Next one we have the covalent radius. This is the radius is measured for the atoms or molecules which are formed due to the covalent bond. So like if you take the simply Cl2 molecule. So one chlorine is bonded to the another chlorine through the covalent bond. So in case of if you take the chlorine molecule, this is one Cl2 molecule. This is another Cl2 molecule. So this is the nucleus of one of the atom of this molecule. This is the nucleus of another molecule, one of the atom of another molecule. So the distance between these two molecules. So the half of the internuclear distance between the two adjacent atoms of a covalently bonded molecules. The distance we call as the covalent radius. Half of the internuclear distance between two adjacent atoms of a molecules which are bonded through the covalent bond. Such distance we call as the covalent radius. Always covalent radius is more than the metallic radius. Then now we are going to discuss how radius changes when atom converts into ions. So now we are comparing the, now already you know that what are the types of ions we have. We have the cation, atom and anion. Now the comparison between the size when atom loses electron or atom gains electron. So we know that when atom gains electron, it converts to anion, that is negative charge. When atom lose electron, it changes to the positively charged cation. Like just first you will come to the cation formation. That is the example of, like you take the sodium metal. When we are taking the sodium metal, we know its atomic number is 11. Its electronic configuration is 3s1. If you write the full configuration, it is 1s2, 2s2, 2p6, 3s1. So now if you consider that, so the distance from the nucleus to third shell we called as the atomic radius in case of this sodium. And it is having the atomic number means it has the 11 electrons and it has the 11 protons. Then when the sodium lost one electron, when atom lost electron, it converted to its ion. So when atom converts to its ion, no change in its atomic number. Then when we come to that, it has lost the 1 electron by the, actually it has 11 electron. If it lost 1 electron, it has 10 electron. No change in its proton, it has the 11 protons. So it has 10 electrons and 11 protons. That means which charge is more? Electron. Negative charge is more. Sorry, electron. Negative charge is less. Positive charge is more. So how many units? Positive charge is more by 1 unit. That's why it is Na plus. It is Na plus. Now if you write the electronic configuration, it has the 1s2, 2s2, 2p6. So if you observe very clearly, now if Na plus ion, it has the lost electron only in the second shell. Then from the nucleus to second shell we considered as the its atomic radius. Then in case of atom, it has the distance from nucleus to third orbit. When it comes to the ion, nucleus to the second shell, then clearly is visible to is that the size is decreases. That means when an atom converts to its cation, its size decreases. So not only here, in case of here the shell decreases, but when we come to the other atoms, when we come to here that here 11 protons, here 11 protons, here 11 electrons and 10 electrons. So 11 protons can hold 10 electrons more strongly than the 11 electrons holding the 11 protons holding the 11 electrons. So here 11 protons, 10 electrons. Here the nuclear charge is more. So due to the increase in nuclear charge, as we discussed earlier, as the nuclear charge increases, atomic radius decreases. Then when we come to the cation and atom. Which has more size? Cation and atom. Atom has more size than its cation. Atom has the more size than its cation. Then when we come to the anion, the just example we will discuss is chlorine. The example which we discuss is chlorine. We know atomic number 17. It has the atomic number 17 and electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. Now this is the nucleus and last electron is present in the third shell. The nucleus to the third orbit is called the radius for the chlorine. Radius for the chlorine. Then it has the atomic number 7. It has the 17 electron and protons are also 17. Then this chlorine gains 1 electron. When chlorine gains 1 electron, it has 17 electron. Then atom converts to its ion, no change in its atomic number. It has 17 atomic number. Electrons, it has 17 electron and gained 1 more electron. It become now 18 electron. And the number of protons, no change in its protons. Then if you come to here, 17 protons are holding 17 electrons. Here 17 protons are holding the 18 electrons. 17 protons are holding the 18 electrons. Here the nucleus charge decreases. Nuclear charge decreases. So due to decrease in the nuclear charge, then atomic radius increases. Due to the decrease in nuclear charge, atomic radius increases. And here 17 protons and 18 electrons, then negative charge is more by 1 unit. That's why we'll write Cl minus. Then we can say that, so when compared to the anions, anion has the more size than its atom. Anion has the more size compared to its atom. Then, so when we come to the atom and anion, anion has the more size than its atom. Then a cation, then comparison, cation less than atom less than anion. So we have the two examples. Just compare the order of H, H minus and H plus. Then the order is cation, atom and anion. Cation is H plus, then atom is H and anion is H minus. Like in the same manner, I minus, I plus. Then here cation is I plus, I minus. This is the order of the cation, atom and anion. Then when we come to the isoelectronic species, isoelectronic species. Isoelectronic species. So what is meant by isoelectronic species? Iso means same, electronic, same number of electrons, species. So in case of chemistry, either atom or ions. Atom or ions we considered as the species. So what is the meaning of isoelectronic species? So either atom or ions which are having the same number of electrons, those we call as the isoelectronic species. Either atom or ion which is having the same number of electrons, that we call as isoelectronic species. So like if you consider the N minus 3, O minus 2, F minus, neon, Na plus, Mg plus 2, Al plus 3. Now if you see that nitrogen atomic number 7, it is gained, minus 3 means it gains 3 electron. Actually has 7 plus 3, 10 electrons. Oxygen number of atomic number 8, minus 2 means it gains 2 electrons. 8 plus 2, 10 electrons. Fluorine atomic number 9, minus 1 means it gained 1 more electron. 9 plus 1, 10. Neon atomic number 10, it has 10 electrons. Sodium atomic number 11, it plus 1 means it lost 1 electron. 10 minus 1, 11 minus 1, it has 10 electrons. Magnesium atomic number 12, it has the 12 electrons, plus 2 means it lost 2 electrons. 12 minus 2, 10 electrons. Aluminum atomic number 13, it has the 13 electrons, plus 3 means it lost 3 electrons. 13 minus 3, 10. So all these ions, it said these are anions, atom and cations. All these are having the same number of electrons, that is 10 electrons. So in case of isoelectronic species, as already we learned that anions are having the more size than its atom. So here N minus 3 has more size than O minus 2, then F minus. Isoelectronic species. What is meant by isoelectronic? Iso means same. Electronic means electrons. Species means atom or ions. So either atom or ion which is having the same number of electrons, those we call as isoelectronic species. Then N minus 3, nitrogen atomic number 7, it gains 3 electrons. Then total it has 10 electrons. Oxygen atomic number 8 and minus 2 means gains 2 electrons. 8 plus 2, 10 electrons. Fluorine atomic number 9, minus 1 means it gains 1 electron. 9 plus 1, 10 electrons. Neon atomic number 10. Sodium has 11 electrons, plus 1 means it lost 1 electron. 11 minus 1, 10 electrons. Magnesium atomic number 12, plus 2 means it lost 2 electrons. 12 minus 2, 10 electrons. Aluminium atomic number 13, plus 3 means it lost 3 electrons. Then 13 minus 3, 10 electrons. Then these all the ions and atom, all those are having the 10 electrons. Then these all set of atoms, we can call it as the isoelectronic species. So how can we compare the sizes of isoelectronic species? The simple one you remember, as in case of anions, isoelectronic species, for anions, negative charge increases, its size increases, and cations, positive charge increases, its size decreases. Isoelectronic species, as negative charge and anion increases, its size decreases. For when we come to the cations, isoelectronic species, as the positive charge and cation increases, its size decreases. This is the order of atomic radius in case of isoelectronic species. I hope friends, all of you understand this concept well. Then we will meet in the next concept in the another video. So I am here to discuss with ionization energy. As in the previous videos we discussed about valency and atomic radius. Now we are going to discuss about the third property, that is ionization energy. So ionization energy, this is also called as ionization enthalpy. Enthalpy is nothing but energy. This we can write it as IE, ionization energy. So in the definition, what is the definition of ionization energy? So that means here only is there ions, atom converts to ion. So the amount of energy, ionization energy is defined as the amount of energy required to remove the electron from the isolated gaseous neutral atom. Ionization energy is defined as the amount of energy required to remove the electron from isolated gaseous neutral atom. So here different terms are there: isolated, gaseous, neutral, atom. Isolated means generally you know that, so whether it's a solid or liquid or gases, between one atom to another atom there will be a force of attraction. So we need to break down all the force of attractions and we need to get the single atom. So mostly individual atoms are available in the gaseous phase. That's why isolated, gaseous. So isolated means separated. That compound should be in gaseous phase, and neutral. We have to remove the electron from neutral. When the atom neutral, when it is in atomic state only, it's neutral. If it lost or gained the electron, it becomes the ion. So neutral means it is the meaning of atom. Isolated, gaseous, neutral, atom. So we know that here electrons are present in the extranuclear shell and protons are present at the center of the atom, is called nucleus. So between these positively charged nucleus and negatively charged electron, there will be always attractive forces. There will be attractive forces. So we need to break these attractive forces and we need to remove the electron. We know that to break anything, we need certain amount of energy. So here also, to remove or to take it out this electron from this attractive forces of nucleus, we need certain amount of energy. That amount of energy which is required to remove the electron from neutral atom, that energy we call as the ionization energy. So we take to break anything, so energy is taken out from our body to break. Here also, to break this one, we need to give the energy from the outer source as in the form of heat or light. Then it is a absorbed amount of energy, absorption energy, that is endothermic or exothermic. So it is the endothermic absorption of energy. So ionization energy is endothermic. The next, so if you consider an atom, how many ionization energies are possible? So always the number of ionization energies for a given atom always equal to its number of electrons. Like if you take the helium, it has only 2 electrons. It nothing but it has 2 ionization energies. If you come to the oxygen, it has atomic number 8. It means it has 8 electrons. Then it has the 8 ionization energies. Like if you come to the fluorine, it has 9 electrons. It has the ionization energies 9. So every atom have the number of ionization energies is equal to its atomic number or the number of electrons. Then, so the first, if you take metal, use general M refers for metal. So I am removing the first electron from the metal. Then by the removal of 1 electron, it becomes as M plus and it lost 1 electron. This we call as first IE, first ionization energy. Then this we call as, by the loss of 1 electron, what is the ion resultant, that we call as unipositive ion. Unipositive ion. So the amount of energy required to remove the electron from the unipositive ion to form a dipositive ion, that we call as second ionization energy. Always second ionization energy is greater than the first ionization energy. That is only due to the increase in nuclear charge. Then how it changes in groups and periods. So first, in case of groups, so when we come to the groups, so the first general will discuss first group, that hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So when we come to the down to the group, as atomic size increases, then ionization energy decreases. Then when we come to the period, so like second period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So when we come to the left to right, its atomic size decreases. Atomic size decreases. Due to decrease in size, its ionization energy increases. Then this is the order of ionization energy. But here some exception is there. Then when we come to their electronic configuration, it is 2s1, 2s2, 2s2, 2p1, 2s2, 2p2, 2s2, 2p3, 2s2, 2p4, 2s2, 2p5, 2s2, 2p6. Then if you come to here beryllium and nitrogen, as we learned in structure of atoms with either O-filled or completely filled electronic configuration, they are more stable. So here beryllium has the completely filled s orbital and nitrogen have the off-filled p orbitals. Due to that, they are having some exceptional electronic configuration, electronic ionization energies. So here in the group, in this period, beryllium has more ionization energy than boron. Even nitrogen has the more ionization energy than oxygen. This is the exception in case of periods. So generally when we come left to right, ionization energy values increases due to decrease in the size. Then beryllium and nitrogen. Beryllium has completely filled s orbitals and nitrogen having the off-filled p orbitals. So either any atom or ion having the off-filled or completely filled atomic orbitals, they have the extra stability. Due to this extra stability, it is difficult to remove the electrons from beryllium and nitrogen. So beryllium having a little more ionization energy than boron, and nitrogen has the more ionization energy than oxygen. So what is ionization energy? Energy required to remove the electron from isolated gaseous neutral atom. Then units non-ionization energy is measured in electron volts. Group. So in a group, top to bottom ionization energy decreases as a result of increase in atomic radius. Then in a period, left to right, ionization energy increases. Ionization energy value increases due to decrease in the atomic radius. So here beryllium and nitrogen are having the exceptional ionization energy. So in the some books is also given as it's not following regular trends because of this beryllium and nitrogen. So beryllium has having the completely filled s orbital, nitrogen having the off-filled p orbitals. Due to this, they have the extra stability. To remove the electrons from the extra stable atoms, we require the much energy. That's why beryllium has more energy than boron and nitrogen having more ionization energy than nitrogen. So in case of in general, we'll speak in a period left to right, ionization energy increases, or we can say it's not following regular trends. What is the reason? Means beryllium and nitrogen have the off-filled and completely built orbitals. Thank you friends. I hope all of you understand. We will meet again in the another video. So till now we completed 3 sub-concepts, that is in the under periodic properties, valency, atomic radius, ionization energy. Now we are going to discuss about next property, electron affinity. This is represented as EA. Electron affinity is also called as electron gain enthalpy. Electron gain enthalpy. In that only meaning is there. Electron gain. So amount of enthalpy means energy. Amount of energy released when electron is added to a neutral gaseous atom. So what is the definition? Electron affinity or electron gain enthalpy. So the amount of energy released when an atom is, when an electron is added to the isolated gaseous neutral atom. So like if you take the representation of element X is added with electron, then by a gain of electron it becomes as X minus and it releases the energy. That amount of energy which is released, that we call as electron gain enthalpy or electron affinity. So here releases means exothermic. Releases means exothermic. So how many electrons is added to an atom, that many electron affinities are present. But always first electron affinity is exothermic, second electron affinity onwards, the remaining all electron affinities are endothermic. Like if you do this, so one electron is added, this we call as uninegative ion. Now this uninegative ion gains one more electron, is become to dipositive ion. Then this dipositive ion, so to form this dipositive ion, always it takes the energy. This is endothermic. So how it changes in group and periods? So in general, electron affinity values are also decreases in case of group, and the same reason. So in a group, top to bottom atomic radius increases due to that electron affinity decreases. In a period, left to right, electron affinity values increases. Electron affinity values increases. Electron affinity values increases due to decrease in atomic size. Atomic size. So generally, in a group, top to bottom atomic radius decreases. Like if you come to the fluorine, chlorine, bromine, iodine and astatine. Then what is the order? Decreases means fluorine has more than chlorine, chlorine has more than bromine, bromine has more than iodine, iodine is more than astatine. But so in any group, second element having the more ionization energy than the first element which are present in the periodic table. So generally decreases means fluorine has more than chlorine, then bromine, then iodine, then astatine. But in any period, the first element having the less electron affinity values than chlorine. So what is the reasons for that? Means one is the smaller size. Smaller size of the atom, and even though high interelectronic repulsions. High interelectronic repulsions. Like if you take the fluorine, so the electrons are present in the second orbit. It has the 7 electrons. Then so if it is coming, it's the 7 electrons. In case of the chlorine also, the 7 electrons, those 7 electrons are arranged in the third orbit. In case of chlorine, the distance between the electrons is a little more in case of chlorine compared to the fluorine. So due to its smaller size, fluorine is smaller size than compared to fluorine. Then electron gain enthalpy. One more is electron is present. Already electrons, there will be a strong repulsive forces, and incoming is also electron. Between these electrons to this electron, strong repulsive forces are present. So we need to introduce the electron. We need to work against these inter-electronic repulsive forces. So we need the energy to overcome these repulsive forces. So that amount of energy is absorbed from the outsource. That's why second electron affinity onwards, it's a endothermic, as well as so they are having the elements whichever may be the present in the first of the group are having this lesser electron affinity compared to the second element. This is the small exception we need to remember. Thank you friends. I hope you understand this very clearly. We will meet in the again next video. We are going to discuss about the next concept, that is electronegativity. So generally till now the properties which we discussed, either valency, atomic radius, ionization energy, electron affinity, these are the properties of individual atom, but electronegativity comes in the molecule. So in a molecule, the ability of an atom to attract the shared pair of electrons towards itself is called as electronegativity. The ability of an atom to attract the shared pair of electrons towards itself is called electronegativity. So simply this, in case of groups and periods, how it changes. In a group, electronegativity decreases, and period, electronegativity increases from left to right. In the same manner, we discuss metallic. So metallic nature in case of group and period. So metallic nature is means generally we can tell in terms of the tendency of loss of electrons, or we can say electropositive nature also. Metallic nature in a group top to bottom increases, in a period left to right decreases. Then non-metallic nature. Non-metallic nature in a group and period. So non-metallic nature in a group top to bottom decreases, in a period left to right increases. So this is the how properties changes in groups and periods. Then all together once we will conclude now how the properties are changed. So periodic property is nothing but the properties which repeated at regular intervals of atomic number is called as the periodic properties. So then property, how it changes in group and how it changes in periods. Then first one is valency. In a group the valency is same, but in periods initially it increases from 1 to 4 and then decreases to 0 for inert gases. Then atomic radius, or we can call it as atomic size, group increases, period decreases. And ionization energy, IE, ionization energy decreases in groups, increases in periods. Then electron affinity or electron gain enthalpy decreases in groups and increases in periods. Then electronegativity decreases in group, increases in periods. Metallic nature increases in group and decreases in periods. Non-metallic nature decreases in group and increases in periods. So these are the trends in the periodic table, how those are changes in periods and groups as a glance. Thank you friends. I hope everyone understand these all periodic properties very clear. So we will meet in the next concept in the next video. Thank you everyone.